Greetings, mathematicians, and welcome to Primetime Investigation 3.1. We are talking about this very big word called prime factorization. Yeah, we're going to talk about it. You may have seen this on your I-Ready test, but now we're going to talk about it. So, our focus question, if you could go ahead, pause the video, write this down, please. How can you find the prime factorization of a number? Now, before I show you how, let's talk about some key vocab words that are going to help us today. The first word we're going to talk about is factorization. What does it mean to factorize a number? What does it mean to find the factorization of a number? And this is different than prime factorization, but factorization is just this, a number broken down into a string of factors. And we're going to take a look at an example here. So there are many ways that I could write the number 24. When I find the factorization of 24, really what I'm doing is I'm rewriting this number as a multiplication problem. So for example, I can rewrite it as 1 times 24. This is what I call a factorization. But you'll also notice that I could write this in other ways. I could write this like this. I could say 1 times 8 times 3. So now I have 3 factors here. But does it still equal 24? Yes, it does. I could write this a different way. I could say this is 1 times 4 times 2 times 3. Double check. Does that still equal 24? Yes, it does. I could write this one more way. I could go 1 times 2 times 2 times 2 times 3. Does that still equal 24? You'll notice that it does. And this very last one, this very last string of factors or factorization is super important because this is what we call prime factorization. Well, what does prime factorization mean? Excuse me. What does prime factorization mean? Well, it has a very, very similar definition to what factorization is, but there's one key difference. So we'll say that this is a number broken down into a string of, here's the key difference, of prime factors. Notice how the very last factor string we wrote, the 1 times 2 times 2 times 2 times 3, look at those factors, please. Are they all prime numbers? Yes, they are. So that is what we're talking about. We're going to be breaking down numbers into lists, into these factor strings of prime numbers. So this right here is the prime factorization of 24. So I know what you're thinking. You're probably thinking, well, Mr. Archie, this 1 times 2 times 2 times 2 times 3 is very long to write. I would agree with you there. So we could actually rewrite this in another way, using something that we call exponents. And that's our third vocab word for today. So exponents are really nice because think of it like an abbreviation almost. So exponents, the definition that we have for exponents, it's the small raised number that tells you how many times a factor is used. That tells you how many times a factor is used. Let's take a look at an example here. Here's an exponent for you. I take the number 2 and I raise it to the exponent of 2. I can read this as 2 to the power of 2. What this means is this little floating number here tells me how many times do I multiply 2. I'm going to multiply it 2 times, so I can rewrite it like this. So 2 to the power of 2 is the same thing as saying 2 times 2. If I write 8 to the power of 4, this little 4 tells me how many times I'm multiplying 8. Well, I should have 4 eights. 1, 2, 3, 4. So 8 to the 4th power is like saying 8 times 8 times 8 times 8. So that's why exponents are really nice. It's a short way to write something that might take a little extra time. Well, let's take a look at the prime factorization example. 1 times 2 times 2 times 2 times 3. I notice that I have 3 2's here. How could I rewrite this as an exponent? Well, you just take the number 2, because that's the number that's being multiplied, that's the factor. And how many times does it repeat? 3 times. There are 3 2's there. So I say 2 to the 3rd power, and then I just bring everything else down. So I have 1 times 2 to the 3rd power times 3. Just another way to rewrite the prime factorization. Okay, we'll get more practice with this, I promise. Now comes the time when we're going to answer our focus question. How can you find the prime factorization of a number? I'm going to show you how. We're going to use these lovely things that we call factor trees. These are some of my favorite things to write. We use factor trees. Now, we call them factor trees because they kind of look like trees. So, what you're going to do, you're going to start with the number you're trying to break down into its prime factorization. So here's an example. I'll call this example 1. We have the number 84. And you're going to draw 2 little branches underneath it. Okay, now, your job, find the smallest number that's not 1. Find the smallest number that goes into this number. You'll notice that this is an even number, so automatically, the smallest number is 2. So I'm going to write that on the left side. And what I'm going to do is I'm going to put a circle around this 2 because it's prime. Now my job is to figure out, well, 2 times what equals 84? Think about that for a second. I know that 2 times 42. 2 times 42 is 84. So I'm going to write 42 in the next, underneath the second branch. And now we continue. We continue breaking down this number. Except now I'm looking at not 84, I'm looking at 42. I'm going to continue the breakdown process. So I'm going to draw 2 more branches underneath 42. Now again, I ask myself, what's the smallest number that goes into 42 that is not 1? Automatically, 42 is an even number, so you should say, hey, 2 is the smallest number that goes in. So I'm going to write 2 on the left side, and I'm going to circle it because it is prime. Now your job is to tell me, well, 2 times what equals 42? 2 times 21. So 21 is what I'm going to write on the right side, underneath the right branch. Now, I need to ask myself, can I break down 21 even further? Hopefully you said yes. So I'm going to draw 2 branches underneath it. Again, ask yourself, what is the smallest number that goes into 21? That is not 1. 21 is odd, so 2 is not going to work here. Let's try the next one. Is 3 going to work? 3 times what equals? 3 does work. So I'm going to write 3 on the left side. And I'm going to circle it. Why? Because 3 is prime. All right, now 3 times what equals 21? Hopefully you said 3 times 7. Now ask yourself, can I break down 7 even more? Or is 7 prime? Hey, 7 is prime. Once you have circles around each number, right, that means you're finished. So what we need to do is we need to write the factor string of 84, or the prime factorization of 84. So let's take a look. I have a 2. I have another 2. I have a 3. And I have a 7. When I multiply these together, it should equal 84. If it doesn't, double check your work, please. Okay? Now I need to ask myself, could I rewrite this using exponents? Do I have any repeating factors? Yes, I do. I have 2 2's, so I can rewrite this as 2 to the 2nd power, because I multiply 2 twice, and then I just copy everything else down, times 3 times 7. So this is an acceptable answer, and so is this. And there you have prime factorization. We're going to walk through 2 more examples. All right, let's try example number 2 here. I want to break down the number 32 into its prime factorization, into its prime factors. So, draw 2 branches underneath it. Think about this. What is the smallest number that goes into 32 besides 1? Automatically, you should say it's 2 because 32 is even. So 2 is the smallest number that goes in. So I'm going to put a circle around it because it's prime. Now, 2 times what is 32? Hopefully you said 16. So 16 goes on the right side. Can I break down 16 even further? Can I split it into 2 factors? Yes, I can. So I'm going to draw 2 more branches underneath it. Hold on, sorry. I'm going to change how I labeled this. I'm going to put a box around that because that's example 2. I don't want you to get confused. Okay, 16 is even. So 2 is the smallest number that goes in. So can 16 be broken down? Yes, it can. 2 times 8 gives me 16. So I ask myself again, can 8 be broken down? Yes, it can. It's even. So I draw 2 branches. And automatically I know 2 is the smallest number that goes into 8. And 2 times 4 gives me 8. Can 4 be broken down even further? Yes, it can. We're going into the rabbit hole here. 2 is the smallest number. I know that 2 times 2 equals 4, and 2's are prime. So it looks like the prime factorization for 32 is 2 times 2 times 2 times 2 times 2. To check your work, does it equal 32? Does it? Check it, please. If it does, you're good to go. I can also rewrite this using exponents. What's nice is actually it's the same factor being multiplied over and over. How many times am I multiplying 2? 1, 2, 3, 4, 5. So I can rewrite this as 2 to the 5th power. And both of these answers are acceptable. And there we go. Let's do one more example, folks. I'll put these in boxes rather than circles, so that way they're not as confusing. All right, let's do Ooh, here we go. Let's do the number 94. Because I want to show you what happens with this in this case. So ask yourself, what's the smallest number that goes into 94? Remember, 94 is even, so automatically your brain should say, hey, 2 is the smallest factor, and 2 is prime. So 2 times what equals 94? Well, 45 times 2 is 90. 46. 47. Is that what you guys got? 2 times 47 is 94. There we go. All right, now we need to ask ourselves, can I break down 47? Well, it's odd, so I know 2 is not going to work. Does 3 work? I don't think so. Does 4 work? Well, 4 times 12 is 48, so no. 5 doesn't work. 6 doesn't work. 7? 7 times 7 is 49. 8? 9? 9 times 5 is 45. Uh-oh. I think 47 is prime. That's because it is. So our prime factorization for 94 is just 2 times 47. And that's our answer. All right, I want to take a look at questions that are actually kind of like the reverse of this. All right, go ahead, pause the video, write down this question. The prime factorization of a number is 2 to the 4th times 3 to the 2nd power times 5. What is the number? So remember, prime factorization just means we've broken down a number into its prime factors. And what do we do with factors? We multiply them together. Okay? So let's take a look at each of these parts. So 2 to the 4th. 2 to the 4th power is the same thing as 2 times 2 times 2 times 2, right? I multiply 2 4 times. Let's take a look at 3 to the 2nd power. I multiply 3 times 3 2 times. And then the very last number is just 5 multiplied by 5. So if you type this into your calculator, 2 times 2 times 2 times 2 times 3 times 3 times 5, you should get your answer. And it looks like our final answer is, I'll let you type it in. Go ahead, type it in. 720. So 720 has the prime factorization 2 to the 4th power times 3 to the 2nd power times 5. You see how we're working backwards here now? I give you the prime factorization and you're going to tell me what is the original number. All right, let's work through one more example. All right, go ahead. Take a moment, pause the video, write this question down. All right, the prime factorization is 2 to the 2nd power times 3 to the 2nd power times 7. What is the number? Now, I want you to go ahead and pause the video and see if you can answer this question on your own. All right, hopefully you paused the video, hopefully you tried this. Let's see what happens. I know that 2 to the 2nd power is the same as 2 times 2. I know that 3 to the 2nd power is the same as 3 times 3. And remember, I'm just multiplying all these things together. And then I have this lonely 7. So I type this into my calculator, 2 times 2 times 3 times 3 times 7, and that should give me my number. And that number is 252. All right, that's our notes on prime factorization. In the next lesson, we're going to see how prime factorization can help us find the least common multiple, and then in the lesson after that, we can see how prime factorization helps us find the greatest common factor. Okay? All right, kiddos. I'll see you in the next lesson.